If we can what?
Make our own pattern. Remember that you have shown us patterns.
Oh, okay. Do you want to make your own pattern? Yeah, just really quickly.
Oh, of course.
Yeah.
Maybe at the end, if you like.
Yeah, we could do that. All right. So you guys were curious about patterns? We want to look some more into that. Maybe we can do that at the end a little bit. I showed you where it is.
Yeah.
You simply extrude. The trick is it has to attach to those 4 points.
Right.
Then you can apply it in. Oh, but you want to make your own pattern. You can't, unfortunately, can't make your own patterns.
Okay.
You only have those. I think I misunderstood the question. So there's making panels
Right.
is one thing. So you can make panels. To make your own pattern, those are what they are. There's a lot of them. The trick is to pick one that's closest to where you want to get to, and then you can adjust the pattern from there based on those parameters it gives you.
Because that's what when we did the workshop last year, I remember we did a lot with the patterns and the panels.
Okay.
I think a lot of where we got some of our forms was that figuring out the way to make the pattern and the panel work to make that, and this is what you want it to be. So I think maybe that's where I was thinking that we could adjust the pattern, but I guess it was just the sort of parameters of that pattern that we can adjust with the panels to make it what we want.
Yeah, so there's a little bit of what you can do with the panel. So yeah, but if you go back to this guy and you divide the surface, if I were to divide this, I only have these pattern options. That's all I've got. But if I come back to the family and I do the pattern-based family here, the things that I can draw in here can then go be applied to that pattern. So some of how you make this can alter what you've got a little bit as well. Cool, good questions. That's the good and the bad. When these family things are made, the easier it is, the less options you have. The more challenging it is, the more open-ended it is, the more you can do. So we're going to switch gears a little bit and not that that's easy by any means, but there are some limitations, there are constraints in that patterning. But you can make any pattern you'd like to in Dynamo. The trick is figuring out how to do it. So we're going to go ahead and look at Dynamo and start to build a couple of patterns, a couple of shapes, and then we'll try to control one of these Revit families. And I will say, in a workshop like this, it's impossible to learn everything. It's just simple. There's just not enough time. So the trick, people ask me, how did you learn everything in Revit? And it's a little bit at a time. There's a lot of resources out there, luckily, which is nice. When I first started many years ago, I bought books. I would read about Revit on the bus and try to stay awake through those thick books. But a little bit at a time, trying to conquer little pieces at a time, and that's the trick to doing it. Sometimes students try to do everything in their project all at once, all amazing Revit, but stick with your small victories. If you can get a pattern to work really well, or if you can get one Dynamo definition to work really well, call that a victory. And then your next project, next semester, you can do a little bit more, and then work that way. Try to master a skill, move on to the next. All right, so Dynamo, just to go over that, I just get a sense. Is anybody using Dynamo already? Or is this pretty new to everyone? So no idea to a little bit? Okay. Cool. So Dynamo, once you've got it installed, you'll find it over in the add-ins. So this is Dynamo right here. So I've got Dynamo here, and I open it up by clicking on it. You can see I've got a couple of versions. As you do new versions, they start to stack on each other. And Dynamo sits on top of Revit. It's not a separate program, so you can't Alt-Tab over to it. It's actually just a really big window sitting inside of Revit. So if you have dual screen monitors, that would be ideal. Otherwise, you have to kind of put it on top and move it around to see Revit in the background. Here's the basic interface. Dynamo can do several things, but I break it into two categories to get a basic understanding. You can create shapes and geometry in Dynamo itself. That is actual geometry. You could then bring into Revit or bring to another program. And that's using Dynamo to create geometry. So that's option one. There's a category of tools there for that. Option two is you can use Dynamo to control geometry that's in Revit. Working like a puppet master, you're tugging the strings and making Revit dance, essentially. And you can control anything from sheets to doors, schedules, geometry, anything in Revit you can control with Dynamo. Now the communication is two-way. You can send things from Dynamo to Revit, or you can take information from Revit back to Dynamo. So they do talk to each other. And you could also bring in other tidbits of information as well. You can bring in spreadsheets. And so examples I give, if you have a spreadsheet, if you're doing a project like some sort of historical museum, and you have a bunch of data on birth rates or some other historical data, you can bring that in as an input into Dynamo, an Excel spreadsheet, and then let that start to define geometry. Use it as a process of exploration and let that define geometry. Or you can go the opposite direction, get some information from Dynamo and export it out to Excel. So you can go both directions. You can also bring images into Dynamo. So again, if you go back to that historical museum example and you have some historical images and you want to translate that into geometry somehow, you can bring those images into Dynamo. Dynamo can read the color values, which generates a number, which then you could use that to inform geometry. And the thing that's underlying, what's laying below under the hood in Dynamo is math. So again, taking you back to geometry class in high school, X, Y, Z is really important in Dynamo, and numbers are important. Without numbers, you can't really do anything significant in Dynamo. So we're going to jump right in here, and we're going to come in, and I've got the interface of Dynamo. I've got two buttons, new and open, so it's opening a new Dynamo. They're called definitions. And inside a definition in Dynamo, there's nothing but a computer program. There's no real geometry. When you save these files, if you're able to open them up, it's just a bunch of text. A computer program is all it really is. So you can start a new one, or you can open from an existing. You've got your Revit files here, or I'm sorry, your recent files. Under that, you've got sample files, and quite a few of them. So if you wanted to do, we won't have time today to look at some of these, but Dynamo controlling colors in Revit, bringing Excel spreadsheets into Dynamo, all these, you're using an image in Dynamo. You've got sample definitions here. So these are really helpful when you're learning to reverse engineer these. And there'll be little instructions in these that will say open up such and such Revit file. When you download Dynamo, it also installs or copies over a couple of Revit sample files that you'll need to run some of these sample definitions. So just know these are here, and it's a good place to start, reverse engineer those, figure out how somebody else did it, and have a starting point. Over here you've got discussion forum, and you've got dynamobim.org. So these discussion forums are monitored actively, and there's an active community. So posts, I see some students spend so many hours just researching online, Google searching. But go ahead and be the person that posts a question to the forum and get answers. And you'll be surprised. It takes a little bit of patience. You don't get the immediate answer, but it comes pretty quick, and you can get join the conversation. And that gets that self-promoting. You get your name out there, and which helps when you get jobs. You can say, oh, I'm on this forum and that forum. And you can get to know people who can help you and mentor you and learn Dynamo. Because it's not easy. So it's not always about what you know, but who you know can help you get through this. There are also PDF tutorials and video tutorials. And I highly recommend, if you get into Dynamo, come watch these video tutorials. They're iterative. So start with video 1, and I think they go up to like 10 sections, and watch them in order. And that will help your Dynamo knowledge and abilities grow tremendously. But again, don't zoom to the one that has the interest you're in. Start with one and work your way up because they build on each other. All right, and there's a GitHub repository, and if you have bad bugs, you can send issues. The other thing to know is it's Dynamo, which is D for dangerous. You're writing a computer program. So you can write loops or make a computer process something that's going to make it process for a very long time or crash. Again, because we're designers, not professional programmers, it's really easy for us to do that, especially when you're learning. So close your other programs for your work in Dynamo. That term paper you have opened up in the background in Word that you spent all night working on and didn't save it and close it before you work in Dynamo, because you can make your computer do crazy things. You can think of Revit. It's a very sophisticated program written by some of the best professionals out there, and it can still have issues, right? Cause your computer to crash. Imagine you writing a program who's learning this. It's really easy to make a program that will make things crash. So just know when you're learning, especially, or anytime, close everything else down and just work in Dynamo. All right, so we'll make a new definition. So in Dynamo, click on New. A couple of things about the interface. On the left, you've got a library of some different functions. So that's here on the left. And you can see there's a bunch of these. These are all of the nodes that you build in Dynamo, little nuggets of program that take inputs and spit out outputs. Those are on the left. Your working window is on the right. And it has two modes at the very bottom right. You've got geometry. If you click on that and zoom in and out, you're controlling the 3D workspace in the background that shows your geometry. If you click on the node button, you're controlling your nodes, which we don't have any nodes or connectors yet. But node versus geometry. All right, you've got some basic file save commands, edit, undo, some view commands, libraries. And again, those help options are repeated again here. Same on the home page. All right, so let's get started. So over here on the left, I've got my operations. First, I got my core operations. These are the basics: color, evaluate, file, input, strings, other things you can input and view. These are basic operations. So if I click on input, you can see all the inputs that are basic inputs you can bring in. And you'll see a couple names here. You'll see double. When you see the term double in Dynamo, if you're taking notes, that means decimal points. So 1.1, 1.2, 1.3, and so on. If you see integer, who remembers what integer means from high school math? Whole numbers. So 1, 2, 3. It's going to skip from 1 to 2. So it's a chunkier movement. You're going on a grid versus doubles. It's very smooth. Number is a number. A string. Has anyone taken computer programming courses know what a string is? Any guess?
A collection of operations.
It's actually text. So you can type operations. Any text you type would be a string. So that's computer programming speak for text. Why don't they just call it text? I don't know. It's called string. So we're taking notes again. Double, integer, number is pretty self-explanatory, and then string. Code blocks, you can type a whole block of code. Booleans, you can add objects. And it gives you a little, if you hover over these, what's really helpful is it tells you on the right a little description. Those are my core operations. Geometry. This is all the geometry that I can create here in Dynamo. So I can make cylinders, curves, edges, cubes, cones, circles, and so on. I have a bunch of Revit options. So here's where I can send and get information from Revit and be that puppet master controlling Revit. I can analyze. You'll see there's some daylighting analysis options in here. So you can actually use Dynamo as a building analysis tool. You also have some rendering options here. So if you wanted, for instance, to render the project every half hour throughout the day and do that automatically, send it to the cloud and then give you the results back, you can do that. So you can see here it says send to cloud render. Again, you're like puppet master. You could do that yourself. You could send 12 cloud renders off or more, but you could actually set an automated process to do that. And the reason why you might want to do that is to test lots of design options to find the optimal. As humans, our time is limited, so maybe we can test 4 or 5 design options. If I use Dynamo, I can have it test design options for me. Maybe I can do 200, 300 design options. So that's why you might, one reason you might use Dynamo. I've got units, so area and length and volume. I've got some functions I can do. These are more programming functions, so lists and values, if statements, if this, then do that. Operators are basic math operations. So I've got divide, multiply, add, subtract, greater than, equal than, less than, absolute value. Office, this is where I can read and write Excel spreadsheets. And migration is where we'll start. This is some basic modeling, again, back to geometry class. So we'll start off by doing what's called XYZ grid. So if you guys click on that, click only one time, and that will place your node. If you double click, it makes more. So just do one click. If you did a double click, you can delete them by selecting them and hit delete. And move that up to the upper left-hand side. And now we can put some inputs into these. The hardest part in Dynamo is figuring out what inputs it needs to get a good output. And sometimes when you're learning, it just takes some experimentation to figure that out. So on the left, I've used this one, I know what it is. The X, Y, and Z count, it's going to make a grid. It's going to make a grid across my geometry area. It's going to have so many points in the X direction, Y direction, and Z direction. Then my X, Y, and Z 0 is the origin. Where does this grid start? And 0 is fine for now, but if I want to put this in a certain place in the Revit project, I might need to adjust that. Then I have my spacing between points. So I'm making a grid. These are the inputs that define the grid, and here's my output. It's going to define a series of points. So I want to come back to my core and my inputs. So core, inputs. Now I want to input a number. That gets a little tedious over time. So once you use a lot of these nodes over and over again, it might be easier to type in the search. You just type in number, and it will find it for you. You can click and put a number. So you guys are going to need 1, 2, 3, 4, 5, 6, 7 numbers. So you can click on number 7 times and line them up on the left of your XYZ grid. And how this works is you'll have an X, your inputs right here, and these are your outputs, the little right-facing carrots. You click on those. That makes a connector. You can see it's dashed while it's finding a home. I want to put it on X count. It goes solid when they're actually connected. And you can see if I move this around, they stay connected. The way to break that connection is to click on the input, pull it back, and connect it to something else, or click on nothing to disconnect it. So for each of the Y, X, and Z counts, I need a number. For the X, Y, Z zeros, that can all be the same. I want my origin to be right at 0, 0, 0, which is right at the start of all of this. And then the last three will be for your x, y, and z space. And I will connect those across individually. So here we go, x, y, z, and then x0. So you get it to look like this. Now down at the bottom left, you've got two big buttons, run and run automatically. My typical workflow is to click the run button only when I need it. That's going to run the whole program. And that's where if I have a loop or some issue, it can run and run and run. But if I'm confident that I know what I'm doing, it's going to all work, I can click run automatically, and that's going to constantly run the program. So again, danger mode, but we're going to do it right now. We're all about danger. So click the run automatically. We're not doing anything too crazy to cause this to crash right now. So run automatically. And you'll see nothing happened. All of our values are 0, so it's really not making anything yet. So let's start to populate these. In my x, y, and z count, I can start to put in some values. So my x count, I will put in 10. And my z count, I'll put in 10. Let's say I want to use Dynamo to control facade panels. I need to go z count, that's going to go up to make a vertical for a facade. And then my x count will go over to make the horizontal. My y count, I only need 1. So I'll put the number 1 in. 1 row of y. My origin's fine. And now you can see I put a bunch of points. You see a little blue dot appear in yours? That little blue dot has 100 points on top of each other. They're just not going anywhere. So let's spread them out. If I click on the x spacing, let's type in a value of 1.25 for my x spacing. So now my x spacing has spread those out. Each of those points now has 10 points on top of it. Now I can do my z spacing, and I'll also do 1.25. And now it's created a grid. And that's all we need to get started. If I want to, just to see what happens, if I change my y count to 10, and I give my y a certain spacing, I now create a whole box of points. That would be better for an entire building, but we're just doing one facade, so we don't want that. I'm going to go change my y value back to 1. My y spacing can be 0. So I'm creating a grid. It can be a three-dimensional grid. It can be a single line of points. It's a very powerful XYZ grid. And now I want to create a separate point, but before I do that, let's save. So if you go up to File, and then Save, you're saving your definition, which is a DYN file. So you can call this a tractor point, or whatever you want to call it. Tractor point with grid, and save this. And what I can do here is now create a second point. So I've got it saved. Anytime I need to save again, I hit the save button. File save. It'll take care of me. Now let's make a point. So if you type up in the search, point, you can see everything that has a point, but the most common one is by coordinates, a double 0y and a double x and a double z. So I click on that one time, and now I've got a point by coordinates. And that can make a single point in x, y, and z, and that's going to generate a point. But we're going to have a little more fun this time. We're going to add in a slider value. so I can adjust the numbers. So if I come in here, under my library search, I can type in slider. And I don't want the integer slider. It's going to jump from 1 to 2 to 3 and so on. I want the double slider. So I click once to make a double slider. And let me zoom into this really quickly. If I'm on my double slider, you can notice there's a little down arrow on the bottom right side of that double slider. And if I click that, I can adjust the range of that slider. And I want my little point to move around on this grid, which has a spacing of 10 by 1.25. So it's about 12.5. So I'll make my max 12 and my minimum 1. I don't really want the point to go to the origin, 0, 0. So I'll say 1 to 12. And you can see as now I have a range, I can slide my slider and you can watch that number grow. So I can move from 1 to 12, every smooth number between that. Once you've got that range, you can minimize that. And you can copy and paste these sliders, or any node really, by selecting it, do Control-C to copy and Control-V to paste. And it will remember your slider options from the first, your min and max. I can minimize that. Now I want to plug these into the Z value and the X value. And you'll note that it makes a little point over here on your geometry. And go ahead and experiment with that. If you move your sliders back and forth, you're moving that point around on the grid. So you need help with that point? You're able to make a little point and slide it around? All right. So now that I've got a couple points, I can start to make something here. So point A to point B. So let's make some geometry. The first one we can try is called line. Line on library. So you can see if I look at line, under line there's create, and I've got 4 options. Best fit through points, by start point and a direction length, by start point and an end point, or by tangency. I've got 2 points, so which one would work the best for me? Excellent, yeah, start point, end point. So that's the logic I use to pick these, by start point, end point. Start point, end point. So there it is. So I can pick my 2 points. So I put my start point as my XYZ grid, and my end point, my little point, as the end point. Plug it in, you can see the results. So now I'm connecting that little point to all of the others. And you can now adjust your sliders around. If you move that point, you can see it's going to connect the dots wherever you move that little point to. All right, so that's interesting. I'm drawing some lines. That's like AutoCAD, it's only so helpful. I want to start making some geometry. So let's go ahead and make some geometry. Anybody help get into the line? Yes, question.
I was not populating, like I was able to get a 10 by 10 grid and then it's not doing anything after that.
Do you have run automatically checked?
Yeah.
You do? Let's see real quick. Let's see if I can sync up. So Dynamo does crash when you have this run automatically checked on. So we've already lost one computer. It can happen. Any other questions? We'll try to give you a second to catch back up. Let us know. I want to go on without you. While he's coming back up, let me just show you guys. A couple of things you can do with Dynamo. So we learned today earlier about adaptive families. You can see adaptive family environment on the right. Dynamo on the left. Dynamo can control points. And as you remember earlier today, we moved points up and down, left and right, in the adaptive family component. You can do that in Dynamo, move points around, and that can adjust, in this case, a roof truss. So it's a very simple building product, a wooden roof truss. You can make a complex roof by adjusting those points.
We're back in business.
You're back in business? Good. Cool. We're looking at making a tractor point today. We'll get into this a little bit more. You can start to create whole geometries with Dynamo and then control them in Revit. This is somebody who's used Dynamo to adjust a crane, actually load it with a load, and then you see the little flags at the bottom will turn green or red if it's too heavily loaded or not. So you can use it for all sorts of analysis. This is a student making a really complex form on the right, wanted to laser cut all of those panels. So he wrote a Dynamo definition to, in Revit, look directly at each one of these panels, and then create a view, and then put the view organized on a sheet to then laser cut. That's pretty sophisticated, right? The student was doing it, but I'm sure that took a ton of time, but at the end of the day, now he's got this tool, he can laser cut things pretty quickly. He can do energy analysis. You can create really complex forms, so it can be a really complex form-making tool. You can make those forms on the right. You can apply those in Revit, add different panels. This is taking a look at using Dynamo to do what we're doing today and applying the parameters to this precast concrete unit. And you can see that the depth adjusts and the opening of the window adjusts. So as the opening of the window gets larger, the concrete block gets deeper, and so the glazing, this is facing south, always stays shaded. So you can model that by hand, or you could use Dynamo to control the whole thing. And we'll look at this in just a second. So you can take the geometry from Dynamo right to Revit, which you can make some really interesting shapes and patterns. You can render those in the cloud, apply filters. Or you can actually control actual Revit geometry using Dynamo. So again, like that Puppet Master, you can adjust and test your design out and adjust the entire thing. So these are some applications for that. All right, so back to Dynamo. So back in business, we're going to delete this line now. And we're going to try to create a cylinder. So if you go to your search area here and type in cylinder, there are two types of cylinder. There's one that's by point and a radius, and one that's by radius and height. Which one would we want to use, given what we're doing? What's a guess? By point. We've got points. And the radius we can define. So I'll click by points, radius. So really simply, it's got a start point and an end point. So point 1 to point 2. And now it's going to create a cylinder between those. If you move your sliders, you can watch that adjust. The radius right now, you can see it's giving it a radius. It's just a default radius. So a lot of these nodes will have a default, and that's fine for now. So now we're actually starting to create some geometry. Question?
What's like the units in Dynamo? Like this 1 to 1 foot, or is it just unitless?
It's kind of unitless. The previous versions, it was more like 1 as a foot, and now it's not so much. So now you have to use some experimentation. There is a ratio. So when I say 1.25 is the spacing, that's actually kind of like 4 feet in Revit. So you can use a little bit of math. There are also some units operations in here. You can kind of play with those and adjust it. But yeah, again, it's an open canvas, so it's a little bit, all those things, even dimensions, are a little bit tricky to play with.
But once you take it to Revit, you didn't have to go and scale it to the specific.
Yeah, we'll connect it to Revit in just a second, so you can see what this will do in Revit.
In the settings, changing the length of display units, that doesn't change those numbers?
Under the settings,
Yeah.
it might affect it. I don't know what the relationship is to Revit,
Okay.
to be honest. But we'll connect it to Revit in just a second. You guys will see firsthand what it does. All right, so let's delete our cylinder. And we'll create one more thing. We'll do spheres now. And again, we want there's a couple of options by points. One wants 4 points. And we don't really have 4 points per se. We want a more simple sphere by center point. I want a sphere at the center of each one of those dots. So I'll do center point and radius. My center point will be that XYZ grid. So I'll plug that in. And you guys will get a series of spheres. And at this point, go ahead and uncheck Run Automatically for now. It's going to start to slow down now that we're making a bunch of geometry. So uncheck Run Automatically. And now we want to create some numbers. We want to do a radius. And I could plug in a number. I could say the radius is 4, and they would all grow. I know the default radius is 1. If I did like half radius, it'll go make them shrink. But I want to start to do something dynamically. I'm using a programming environment to get that. So I want to calculate a value between point A and point B. So I'm going to calculate a distance. So in my library, I'll type in distance. And I'll do distance 2. So right here it says distance 2. I'll click on that one time. And that's going to calculate a distance between the geometry and an entity. In other words, from point A to point B. So I plug in my 2 points. The XYZ grid is the geometry. And my point is the entity. And that's going to spit out a value. It's actually going to be the distance from all the points on the grid back to that main point. So it's going to have a list of 100 numbers. I know it's going to be kind of big numbers, so I want to divide that down. So if I go to my library and clear out distance, and I find my operators, and I find the divide operation right here. So I do divide. I want to divide this down, make it a smaller number. So take my double and plug it into X. And I'll just do another number. So my library, I type in number. I click that once, and I plug that in for Y. And I'll plug a value of 4 in here. So I'm taking the distance between the points and dividing it by 4. And that gives me an output here on the right that I can then plug into radius. And now you guys can click Run one time and see what happens. You'll notice that at that point, the radii of the spheres is really small. There's no distance to itself. The farther away you get from the point, that distance value that we're calculating grows, and therefore the radius of the sphere grows. You can play a little bit risky and do run automatically, or you can change the sliders and click run again. And watch your result change. So now you're controlling a bunch of geometry. You haven't physically modeled anything. You're that puppet master controlling it. So at this point, go ahead and save. And now you've got that geometry saved, or that definition saved. All right, so now I want to use this to control something in Revit and start to build, for instance, a facade with panels on it. So what I can do is clear out my library, and I can delete that sphere node. I don't want to make spheres, I want to make Revit family, so I'll click on the sphere node and click delete. And make sure run automatically is not checked. So I've got a series of points and I've got some values. Now I want to make a Revit family. So over here on the left I find Revit. I find elements. And then elements, let's see. Elements again. And then actions. That's not the one I want. I apologize. Family, instance, create, by point. So that's kind of a lot. So you go family, or I'm sorry, Revit, elements, family instance, create, and then by point. If you want to find this by searching, you can just type in probably family, the word family up here, and that will find it more quickly. Family. Maybe family instance.
Is this creating a family instance? Or
By point. It's going to generate a family instance, yes. Okay, so the point, here's some inputs. It wants to know what type of family, so family symbol, and a point, where to put the family. So I take my XYZ grid point, and I plug it into this point here. Now it's going to generate a family in Revit at each one of those points. We can see the box is still grayed out. That means it doesn't have enough information to do the operation yet. So I'm going to plug in my family symbol. And to do that, I want to do trying to think of the term to search. Well, let's find it. I find them a lot of the time. So I go to Revit, Elements, Selection, and Family Types. So Revit, Selection, Family Types. So Revit, Selection, Family Types. And now you can notice that this has a little drop down. And it's pulling up all of the families in the project that we've created. And you'll see any families will be in here. So if I have, mullions, sheets, whatever, I can start to control those with Dynamo. I want to pick the family that we created at the beginning of our session here. So I called mine wall panel. So whatever you called yours, that's the one that you want to find. So mine was called wall panel. You'll find yours, whatever you called it. And then plug that into the family symbol. And once you've got that, go ahead and click Run. And wait a second. It can take a little moment. And if you minimize this window, you can go to Revit and see it took for you and put your panel in on a grid. I might move and delete some of the other things, get them out of the way. Anybody need help with that? Anybody? All right. So that's fine and dandy. You guys can see how you're now the puppet master. You're using Revit to send this or using Dynamo to build this family here in Revit. So I'm going to go back to Dynamo. And I want to start to control some of the parameters of this family. So if I come in here to my library search, I do type in set par, so set parameter by name. I can click on this. And I can set a family parameter. I can now start to control this family. I'm going to make this a little bit bigger. So this wants 3 inputs. The first one is the family type. So here's my element. So I take my family type and I plug it into element. I want to adjust that family that we just placed. And then the value I have is from my calculation. I've got numbers over here. So that comes from my division node. I can plug in the value. And now the parameter name, I need a string. I enter in some text. So under my search, I'll type in string. Get to my string. And I'll plug it in the parameter name. Now the trick here is to remember what that parameter was called. We did height. That's what I did for mine. I did capital H. I believe that's what I did. Let me go back. You can click on one of those in Revit and you'll see it. Height. It's right here. This is the parameter I want to control. Dynamo is case sensitive, spelling sensitive. So make sure you type it out exactly as you've done it. So I've got capital H. So back in Dynamo, I'm going to type in height, capital H-E-I-G-H-T. That's the parameter I want to control. And once I've got that, I can say run. And it's mad at me. You know what? I steered you guys wrong. I did the wrong family instance. It's from this family instance over. So it should look like this. So family instance by point, that's the element you want to create. The parameter name is height, and the value is our calculated value. So I'll click run, and you guys can see the result. Or should. Value, family instance. Double check my spelling. H-E-I-G-H-T. Oh, it's working. It's working. I don't know why it turned yellow. So you can see it here. So now it's controlling that height parameter. And I can come back to Dynamo. I can adjust my sliders and hit run again. And now it's going to adjust all of that entire facade panel system I have in Revit all over again.
I have a question.
Yes?
So, you have your point. Where is that point on that family?
It's the center of those crosshairs.
Can you change that?
Yes?
Is that hard to do?
No.
Okay. I'm thinking-
I'll just, don't do this, but watch what I do. If I double click on this, it's right here. So the way to change that is to simply move the object somewhere else. Load it back in. So my product will be in the location I just moved it to. It's that simple. So I just moved the object.
Would you open up the Dynamo again?
Yeah.
Let's see that.
So, here's a question.
Yes.
With Dynamo set up like that, do you set up another parameter to control the width of that object?
That's the next thing we're going to do. So yes. You can control as much as you'd like to. So you can see back in my little example here. This one I've used to control the height. Or back here, I did the height and that center circle opening. So you can control as many parameters as you want on a single family.
Within that Dynamo?
Yes. So we'll do it right now.
My question was,
Yes.
within, well, you answered the first question, but within Revit, You could set.
You can still change parameters in Revit, yes,
Okay.
manually.
Uh-huh.
So for instance, if I wanted to come back to Revit and decide that these are all different materials, I can still come back and change the material. That's the other parameter we had.
Okay. But then in Dynamo, you can then control the width based on the center crosshairs.
Yes.
On that point.
Yeah.
As it moves away, the width can increase or decrease.
Yes.
Now, is there a way you can highlight, instead of typing all of that back out again, is there a way you can just copy all of that, or is that just another string that you have?
Good question we're going to look at right now.
All right.
Okay, so let's do the next part. All those questions pertain. So the next part, we're going to control one more variable, and then we'll take a little break. So if you guys go back to Revit and click on one of your boxes, if you double click it, you're back in family edit mode. So we've got a height parameter. Let's go to our floor plan. And let's adjust the width of this thing. So maybe the easiest way to do that, we'll try it together, is to click on this. I say edit extrusion. You'll have to make sure the width lines are parallel. Mine weren't. You can add a dimension in this edit mode, which is another little tips and tricks for editing families. You can add parameters in, I call it the pink line mode. When you're editing shapes, you can add dimensions there. I can select them. I can add parameters in this mode. So add parameter. I'm going to call this one width, and make sure I make it an instance. So width and instance, say OK. Now I hit finish. Mine has a little notch in it, which could be bad because I can actually, if I make the width too small, it could actually not give me a good result. But I'm going to click on family types. Now I've got height and width. I know I can probably make it bigger. So I'll say apply. You can watch that thing grow. Things grow in Revit to the right generally, so I'll probably be okay. So that's why I add that parameter. Now I can load it back into the project. Need to override the version. And you can see I moved that center point and the other, so the whole thing kind of jumps. If I go back to Dynamo now, I can take this entire deal, the set parameter by name, and the string, and I can copy paste that whole thing, Control C, Control V, and now pull it down. You can see it kept all the same relationships and the same values. So that's pretty helpful. And all I have to do is change the string to width. And now if I run this, it's going to control both the width and the height. And it's going to give me an error. Let me fix my family. It's crossing into this little byte. So I'm going to say edit extrusion. I'll make it a little more simple for this example. It's just a box. And I'll say run.
Do they have to be instance parameters?
They don't have to be. They want to be if they're all going to be unique like this. You can see the width parameter may not want to be divided by 4, so I can come back and get more dramatic results in Dynamo. Instead of pulling the same exact number, I can copy and paste this as well. And now you can see your imagination is really the limit. Whatever you want to control in Revit, you can. Run. Smaller numbers to divide by is going to give me a more dramatic result. So there it is. All right, so that wraps it up for this hour, Dynamo. And that's definitely an intro. There's a lot more you can do with Dynamo, and really your imagination's the limit, and your patience to keep plugging away at it. So watch those videos to learn more and join the forum, and in your project, try to, if you want to learn this, your next project, think what's one thing I can control with Dynamo on this project? And limit your scope to that one thing and see if you can get that working. And then the next project you can do a couple of things. So any generic questions before we move on off of Dynamo? Cool. All right, so we'll take another break. We'll stretch it out. Just 5 minutes again. And we'll come back and we'll load up Fusion 360 and take a look at that.
Can we exit Revit now?
You can, yes. Yeah, if you want, you can exit Revit and start Fusion.
I wasn't able to sign up.
Okay.
So I
Yeah.
didn't get any emails for the links or the videos.
Oh, okay.
So would it be possible for me to give you my information, or do you know?
You'll have to ask for that same email if you can get that forwarded to you. And I'll send a follow-up email with some video links. And so same process. We'll get those back to you.
I'm having trouble getting to populate my Revit model. I was able to get all of it in Dynamo, but it's not populating Revit.
Tell me that one more time.
So I'm following what you're doing in Dynamo, but nothing's happening in Revit.
Okay. So you got.